All right. So today we are going to talk about the area. Hey, I think I've started. We're going to talk about the area of a regular polygon. Now, if I gave you the area of a triangle or a square, like you could do that, right? But now we're going to talk about like pentagons and octagons and all of that cool stuff.
Wait, is that right?
Okay, so here's the deal. There's a couple things that we need to know about our polygon. This distance right here, from the center to the side, is called the apothem. Not the opossum, but the apothem. Sometimes I can be funny.
All the time.
Thanks, Ben. Okay. Now,
I knew it.
if we go from the center of our regular polygon to a vertex, we're going to call it the radius, kind of like we would in a circle, but it's not a circle. Okay. Now, these have to be regular polygons. What does it mean to be a regular polygon? All the sides are the same. Okay. If we have a polygon that is regular, all sides are the same, then we can find the area of our polygon by taking 1/2 times the apothem times the perimeter. Okay. Essentially what they are doing with this formula, we can find the area of a triangle by taking 1/2 base times height, right? So what this formula does is it breaks up your shape into triangles. Okay. The apothem is the height of each of those triangles, and the perimeter is the sum of all of the bases. So it's adding up all the triangle area together. That's what it's doing. Okay, but instead of saying, hey, find 6 triangles and add them together, what we can do is we can find the perimeter, we can find the apothem, multiply them together times 1/2. Okay, so let's just look at a couple examples where we are already given the apothem and a side length. Okay, so let's look at number 1. Number 1 is a regular triangle. Okay, it's an equilateral triangle, and I know we could find this a different way, but let's use just for simplicity. Okay, what is our apothem? Our apothem is 7. What is our perimeter? Okay, so take 24. Okay, so if we're going to find the area, then we're going to take 1/2 times the apothem times the perimeter. Nope. So if you'd rather do like this, that's cool.
What about like the X?
That is also cool. Ah, so first of all, what's your number? Okay, and Harvey asked, would it be feet squared? What's your answer? Yes, we're talking about area, we're talking about 2 dimensions, we have square units. Okay. so how about you and your elbow partner work together on finding me the area for number 2? What kind of shape is number 2?
Regular polygon.
A regular octagon.
Is 16 uh,
16 is the apothem. It's a weird word. Okay, so the apothem is 16. Our perimeter is 13.3 times 8, which is what number? Okay, so when you take 1/2 times 16 times 106.4, are you getting 800 and, nope, yep, 51.2?
Yep.
And our label is? Okay, good. Now, how often do you think I'm gonna give you the side length and the apothem? Not very often. Okay, so our main goal today is to work through problems where we have to do a little bit of, I don't know, maybe trigonometry to be able to find either the apothem or the side length. Okay, so here's some things I need you to keep in mind. Okay, you might have to draw a right triangle with the apothem and the radius. Okay, keep in mind that if you don't know anything about the angles, we know that the interior angle sum formula is n-2 times 180. Okay, so if I have a pentagon, how many sides is a pentagon? I would take 3 times 180, and that's the sum of the interior angles. Okay, and then I would know what each of the angles are. Okay, our warm up, we went through a couple special right triangles. We went through one trigonometry SOHCAHTOA problem. Okay, you might have to use that. Okay, there's going to be oftentimes multiple calculations we're going to have to do before we have the apothem and the perimeter. Okay, so let's look at this first one. Okay, what kind of shape are we dealing with? I think it's a hexagon. I think there's 6 sides, right? Okay, okay, it's a hexagon. Now, what I'm going to do is I am going to draw the radius. Why do I care about the radius? How is the radius going to help me? Okay, it creates a triangle with a hypotenuse. If I can find this pink side right here of this triangle, I will have half of one side, and then I can figure out the perimeter. Okay, now, in order to do that, I need to know something about the angles. Okay, so let's go back to, we have 6 sides, right? So if we take 6 minus 2 times 180, how many degrees do these interior angles add up to be? What? 720. And if I have 6 angles that add up to 720, and they're all the same. Okay, so if we have a regular pentagon, we know each angle is 120. So what does that tell us about this angle right here? It is 60. It is. Okay, so we know already that our apothem is 5. we need to do work for the perimeter. So let's go ahead and find X. 5 is which piece of the 30, 60, 90? It's the long leg. How do we get to X, the short leg? Okay, so X is 5 divided by radical 3. Here's something fun for you. I'm gonna let everything be a decimal approximation. Okay. I'm not gonna make you keep this in terms of radical 3. So what you can do is you can take 5 divided by radical 3 in your calculator. Now, if we are going to round and then use that rounded answer, let's go ahead and round to 2 decimal places, since we're gonna have to use it again. So 5 divided by radical 3 is 2.9. 2.9 what?
2.86.
So 2.89. Okay. If I want the perimeter, what am I gonna have to multiply 2.89 by? Nope. I would multiply it by 12 because 2.89 is half of a side. Okay.
So you just take this number by 12 or 2.89 by 12?
Either one's fine. If it's already in your calculator, it's multiply it by 12.
I use the full number, 2.8867.
Okay, so if you use the rounded number, we have 34.68. Okay, so now if we're gonna find the area, we're gonna take 1/2 times the apothem times the perimeter. And we're gonna round to 1 decimal place. So whether you use the rounded answer or not, you should still get 86.7. $6.7.
Wait, 2.89.
No, shoot. What's the apothem, people? 5. I'm so sorry. I looked at the wrong number. Some of you wrote it down right.
I was writing it down, but then I was confused why they were doing them.
Yeah. Speak up. So I know that you might find it annoying that we have to go back and use stuff from previous chapters. However, when we go to take our final, I don't think you'll be disappointed because we've been practicing some of this stuff that we learned previously. Okay, it's actually a good thing.
It's like the number of sides minus 2 times 180.
In order to get the interior angles.
I didn't know they were right on casting.
What?
I thought all was on.
They are.
This
Because
is a
3 minus.
This is a hexagon.
Oh, 3 minus 2. Not all like I get it now. Not all triangles are right triangles. Yes.
I always try and use that.
All right, let's try number 4. Now, we know what all the angles of this triangle is, right? We know that these are all 60, okay? And we know that the apothem is 18. What we don't know is the side length. So what will we need to do? Okay, well, let's first draw the radius. And you're telling me that this is a 30, 60, 90. Okay, so to get I'm gonna call this purple piece, oops, that wasn't good. I'm gonna call this X. You're saying that X is the long leg and we need to multiply 18 by square root 3. Okay, so what is 18 times square root 3? I need 2 decimal places. 1/8. Okay. So our perimeter, we're gonna have to take that purple piece that we found, X. How many of those does it take for our perimeter? We have 3 sides, that's only half of a side. So we're gonna have to multiply it by 6. 30. 30, that's a 30-degree angle.
The whole angle or just the?
Like this guy. Okay, so now to find our area, we can take 1/2 times the apothem. Look, I got the apothem this time, times the perimeter. You good? Maybe. Yeah.
Because I just calculated. I
Uh-huh.
got I got 187.06.
Yeah, I got 187.06.
And that will be okay, because when you multiply by 18 and then times 1/2, are you getting 1,683.7? Okay, so if you're off by 1 decimal place because of your rounding, I will take that into consideration. You're not going to be wrong. Okay. Yes. If you're wrong, you'll be wrong. Ben. Okay. All right. So number 5. Oh, this is fun. How many sides does number 5 have?
5.
It's a pentagon. Okay. How many degrees is each angle of a pentagon? And then divide them by 5. So each angle is 108. That's not awesome, is it?
It's the size and then.
Okay, so 10 is giving us our apothem, right? But if we draw in the radius, we know that this angle right here is half of 108. So it's 54. So how will we find? Okay. Which one is going to help us? Tangent's going to help us. So we're going to say that the tangent of 54 is opposite over adjacent.
Oh my. Is it tangent 54 times 10?
Nope. Yes.
What tangent is it?
I put the line above the 10.
No. No. So we would want to multiply both sides by x. So x tangent of 54 equals 10. So what are you going to put in your calculator? 10 divided by the tangent of 54.
7.27.
Okay. Wait, what? Okay. So how many of those make our perimeter? Remember, that's only half. So 72.7 is our perimeter. Huh? Mhm.
But like it looks like.
Oh, yeah.
What'd you get?
I used the answer from before using the answer button,
Yeah,
but that got me 72.64.
and I told you that's fine. Told you that that's fine. Because when you take that times 10 times 5 and you round to one decimal place, you get 363.5.
Is it 72.7?
Yeah.
I got 80. Oh, I got
363.
I got 363.
Yeah.
Does it round to the 4?
I got 363.5.
Okay,
Well, that's the right.
I have already answered that question.
It looks like the Pentagon. It's a Pentagon.
Okay, I feel like you'll be okay on those problems. Go to the next page. I want to look at number 8. Number 8 is a problem where what can we find right away? Out of the two things we need, we are going to know the perimeter right away. We know that our perimeter is 6 times 22. Okay. Yeah. What do we need to find? We need to find the apothem. That's not very nice. Okay, we need to find the apothem. Stop. He's making a bad joke. Okay. How do we figure out? What are we gonna have to do? Make a right triangle. Thank you. Now, we've already talked about a hexagon, and we've already decided that the hexagon has angles of 120. So we know that this is a 60, 30, 90. Now, here's the deal. Is 22 a side of the triangle? No, 11 is. Okay. So in order to find A, 11 is our short leg. So you can either leave it like that, or you can put it in your calculator to get the approximation of 19.05. So our area is 1/2 times our apothem times 132. To get 1,257.3 yards squared.
Yeah.
Inward.
It has the ball at 5.
Oh, so you have to like pull on it now? Say you have to pull on it?
Okay, are we okay with this? No, we're not? Sure? Okay. Now, I don't know how time has gone so fast. I have so many more problems I wanted to do, but, we won't have time. So I'm gonna pick one more. Oh boy, what? I know. We're gonna skip all the way down to number 14. What are they giving us in number 14? No, they're not. They gave us the radius, which means we need to calculate two things. Okay, so this is, I'm gonna draw in the apothem, and we're gonna need to find X. I don't know why I drew it so it's upside down for you, but I mean, you know what it is, right? Okay, we've already worked with a pentagon, correct? How many degrees was a pentagon angle? 108. So we know that this guy right here is 54 degrees, right?
Yes.
Okay, so what do you want to find first, apothem or X? I like that. The apothem is the opposite side and 19 is the hypotenuse, right? So we need the sine of 54 is opposite over hypotenuse. This is a 19. I don't know why it looks like an A. I hear a 15.37. Okay, so now in order to find the perimeter, we need X. Okay, so for X, X is the adjacent side. So we're going to use the cosine of 54 equals X over 19.
There's a special word that you find.
Ben, what's X? 11.17, 2 decimal places because it's not the
Yeah.
final answer. Okay, now our shape has 5 sides, but that's only half of a side. So for the perimeter, we would need to take 11.717 times. So our area is 1/2 times our apothem times our perimeter for a grand total of 858.4 square meters.
Wait, what setting is the calculator supposed to be on?